Bismillahirrahmanirrahim. Welcome back, dear students. I hope all of you are fine and enjoying good health. This is our 25th lesson, and the unit that we are going to discuss in our today's lecture is transfer of heat. As it is clear from the name of the unit that in this unit we will discuss about different modes of transfer of heat from one point to another point. Students, in previous chapter we discussed about thermal properties of matter such as heat, temperature and internal energy. But in this chapter we will discuss that how that heat is transferred from one point to another point and what is the role of temperature in transferring heat from one point to another point. So the topics that we are going to discuss in our today's lecture are transfer of heat, and then we will discuss a mode of transfer of heat, that is conduction. Conduction means transfer of heat through solids. And then we will discuss thermal conductivity of solids. So before discussing thermal conductivity, first of all we will define rate of flow of heat. Then with the help of rate of flow of heat, we will derive a formula for the thermal conductivity of solids. So students, by the end of this lecture, you should be able to understand that what are different modes of transfer of heat from one point to another point. And then you will have a clear idea that how is heat transferred from one point to another point in case of solids. That is transferred through a method that is known as the conduction of heat. And then you should be able to derive a formula for the thermal conductivity of a solid object. Students, heat is an important form of energy. It is necessary for our survival. We need it to cook our food and to maintain our body temperature. Heat is also needed in various industrial processes. How to protect ourselves from high as well as low temperature needs knowledge of how heat travels. So in today's lecture, we will study various ways of heat transfer. Students, what happens when two bodies at different temperature are in thermal contact with each other? Thermal energy from a hot body flows to a cold body in the form of heat. This is called as transfer of heat. Transfer of heat is a natural process. It continues all the time as long as the bodies in thermal contact are at different temperatures. There are three ways by which transfer of heat takes place. These are conduction, that is the transfer of heat through solids, and then convection, that is the transfer of heat through fluids, and then there is radiation. Now students, the very first mode of transfer of heat that we are going to discuss in our today's lecture is conduction. Students, the handle of metal spoon held in hot water soon gets warm. But in case of a wooden spoon, the handle does not get warm. Both the materials behave differently regarding the transfer of heat. Both metals and non-metals conduct heat. Metals are generally better conductors than non-metals. In solids, atoms and molecules are packed close together, as you can see here in this picture. They continue to vibrate about their mean position. Students, what happens when one of its ends is heated? The atoms or molecules present at that end begin to vibrate more rapidly. They also collide with their neighboring atoms or molecules. In doing so, they pass some of their energy to neighboring atoms or molecules during collisions with them with the increase in their vibrations. These atoms or molecules in turn pass on a part of the energy to their neighboring particles. In this way, some heat reaches the other parts of the solids. This is a slow process and very small transfer of heat takes place from hot to cold parts in solids. So students, how does then heat flow from hot to cold parts in metals so rapidly than non-metals? Metals have free electrons, as you can see here in this picture. These free electrons move with very high velocities within the metal objects. They carry energy at a very fast rate from hot to cold parts of the object as they move. Thus, heat reaches the cold parts of the metal objects from its hot part much more quickly than non-metals. So from this, we can say that the mode of transfer of heat by vibrating atoms and free electrons in solids from hot to cold parts of a body is called conduction of heat. Students, all metals are good conductor of heat. The substances through which heat does not conduct easily are called bad conductors or insulators. Wood, cotton, wool, glass, rubber, all of these are bad conductors, or you can say that these are the insulators. Students, why styrofoam boxes are used to keep food hot or ice cream cold for a long time? Students, styrofoam is a bad conductor of heat. It does not allow heat to leave or enter the box easily. That's why we use styrofoam boxes to keep food hot or to keep ice cream cold for a long time. Now students, the next topic that we are going to discuss in our today's lecture is rate of flow of heat. Students, the amount of heat that flows in unit time is called the rate of flow of heat, and the formula that is used to calculate the rate of flow of heat is rate of flow of heat equals to Q divided by T. Here Q is the amount of heat and T is the time for which that heat is flowing from one point to another point. And the unit of rate of flow of heat is joule per second, because the unit of heat is joule and the unit of time is second. When we shift this unit from denominator into numerator, it will become per second. So from this we can say that the unit of rate of flow of heat is joule per second. Students, conduction of heat occurs at different rates in different materials. In metals, heat flows rapidly as compared to insulators such as wood or rubber. Now let us consider a solid block, as you can see here in this picture. One of its two opposite faces, each of cross-sectional area A, is heated to a temperature T1. This face is heated to a temperature T1. Heat Q flows along its length. This is the length of this block, and heat will flow from this side to other side. Let Q flows along its length L to opposite face at a temperature T2 in T seconds. Small t is the time for which the heat is flowing from high temperature side towards low temperature side of this block. Students, it is observed that the rate at which heat flows through a solid object depends upon various factors. Now students, we will discuss all of these factors one by one. So the first factor that we are going to discuss is cross-sectional area of the solid. Students, large cross-sectional area A of a solid contains large number of molecules and free electrons on each layer parallel to its cross-sectional area, and hence greater will be the rate of flow of heat through the solids. Thus we can say that rate of flow of heat is directly proportional to the area of the solid, which means greater will be the area, greater will be the rate of flow of heat from one point to another point of that solid, smaller will be the area, smaller will be the rate of flow of heat from one end to another end of that solid. And the next factor is the length of the solid, that is affecting the rate of flow of heat in solids. So larger is the length between the hot and cold ends of the solid, more time it will take to conduct heat to the colder end, and smaller will be the rate of flow of heat. So from this we can say that rate of flow of heat is inversely proportional to the length of the solid object, which means greater will be the length, smaller will be the rate of flow of heat, and smaller will be the length, then greater will be the rate of flow of heat. Now students, the last factor that we are going to discuss that affects the rate of flow of heat is the temperature difference. So students, greater is the temperature difference T1 minus T2 between hot and cold faces of the solid, greater will be the rate of flow of heat. Students, here T1 is the temperature of hot phase of the block and T2 is the temperature of the cold phase of the solid block. So the temperature difference between the two phases is T1 minus T2. And this temperature difference is directly proportional to rate of flow of heat, which means that greater will be the temperature difference, greater will be the rate of flow of heat, smaller will be the temperature difference, smaller will be the rate of flow of heat. So students, when we combine all of these factors that affect the rate of flow of heat, then the final equation will become like Q divided by T is proportional to A into T1 minus T2 divided by L. So when we convert this proportionality into equality, it will become like Q divided by T equals to Ka into T1 minus T2 divided by L. Students, here in this equation, Q is the heat that is flowing through that solid for time t, that is represented by small t, and K is the constant of proportionality, that is also known as the thermal conductivity, and A is the area of the solid object. T1 minus T2 is the temperature difference between the two faces of that solid object, and L is the length of the solid object. So students, with the help of this formula or by rearranging this formula, we can also define the thermal conductivity of the solid object. So students, the formula for the calculation of thermal conductivity of a solid object is K equals to Q by T multiplied by L divided by A into T1 minus T2. Thus, thermal conductivity of a substance can be defined as the rate of flow of heat across the opposite faces of a meter cube of a substance maintained at a temperature difference of 1 Kelvin is called the thermal conductivity of that substance. So students, this was all about the rate of flow of heat and the thermal conductivity. Now students, the next topic that we are going to discuss is the difference between conductors and insulators. Students, conductors are the materials in which there are free electrons and they can conduct heat from one point to another point rapidly. Because of the movement of free electrons and because of the vibrations of the atoms, they can transfer heat from one point to another point. So any material that can conduct electricity is known as conductor, such as copper metal, aluminium metal, or you can say that all of the metals are good conductor of electricity because these metals have free electron through which heat can be transmitted or transferred from one point to another point. And insulators are those materials in which there is no free electron. So because of the absence of free electrons, heat is not transmitted or transferred from one point to another point. So any material that do not have free electrons is known as insulator. Now students, we will discuss uses of conductors and insulators. Students, in houses, good thermal insulation means lower consumption of fuel. For this, following measures may be taken to save energy. Hot water tanks are insulated by plastic or foam lagging. Wall cavities are filled with plastic foam or wool. Ceiling of rooms is covered by insulating materials that is also known as the false ceiling. Double glazed window panes are used. These window panes have air between glass sheets that provides good insulation. And students, the handles of all of the cooking utensils are made up of insulators so that no heat can pass through those handles. Now students, this is your homework. The very first question is define heat and write down the names of modes of transfer of heat on notebook. Students, first of all, you will have to define that what is meant by heat, and then you will have to write down the unit of heat, and then you will have to write down the names of modes of transfer of heat such as conduction, convection and radiation. And second question is define conduction. Also write how is heat transferred in solids on notebook. So in this you will have to quote 3 to 4 examples of solids, and then you will have to explain that how is heat transmitted through these solids by the mode of transfer of heat that is called conduction. And third question is define rate of flow of heat. Also derive formula for thermal conductivity on notebook. So first of all you will have to define rate of flow of heat, then you will have to write down its formula and unit. Then by discussing the factors that affecting the rate of flow of heat, you will have to derive the formula of thermal conductivity on notebook. And then at the end of this derivation, you will have to define the thermal conductivity of solids. So students, this is all about today's lecture. I hope now you will have a clear idea about conduction. If still you have any query, you may write down and you can ask in Zoom session. I will answer all of your questions by using whiteboard. Thank you so much and Allah Hafiz.